Whoa. I cannot seem to get my closed captioning to function. I think there's something wrong with the plugin. Hello, everyone. I'd be kind of curious to see if we get the notification of closed captioner not running, because normally that pops up in chat. Even if I don't forget to start it, it does pop up on occasion. So yeah, I don't know. It says it's working, but I don't see anything on the screen. So I'm going to rebuke that as it being borked. So we're going to continue anyway. Yeah. Howdy, Barracks. Yeah, I don't know what its beef is. It says it's working, but the little box that usually indicates the magic behind the madness is showing nothing. So it be what it is. I'm gonna minimize it, forget about it. If it starts working, great, the service is running. If not, well, I kind of don't really care. I'm sure that whatever is broken is probably gonna resolve itself, and if not, well, I'll look into it. So without further ado, hello. Time depending, we're gonna do 30 days in space. We're gonna start with that, and then depending on how long this runs, it may or may not do something else. So we'll see what the time frame looks like here. So, as a bit of a recap, last time, we got our hands on the OLED display, OLED. The thing is 128 pixels wide, 64 pixels high. And with that, we can make pretty pictures. Now, previously, we did an example that showed like a basically hello world message, and it blinked some text, and we got to see what that looked like by setting up basically a loop that made the text appear, and then before the loop would end, it would delete it from the buffer, send it back to the screen, and then draw it again with another delay, which appears to blink as the buffer kind of comes and goes, right, as it cycles. So we're going to continue on day 22 of our 30 days lost in space, which I find to be pretty exciting. We've gotten pretty far through this. So let me get us rolling here. Alright, so we're gonna do that one, and pause that one, and go to the buttons. Okay, let's see what our computer has to say to us.
Good morning, Explorer.
Hello.
I must say, you're absolutely glowing.
Am I
Natural
now?
light suits you.
My face glows in
We're
the dark, so
still afloat
yes.
on this vast extraterrestrial ocean under the celestial sea of stars. Our sojourn into screen text was a step into another universe. What software companies call a user interface. But we're still running into a problem with the information delivery. Even with a display this big, you still need more information and data to work with than text will allow. I know. It's crazy that in a sophisticated, planet-striding, sensor-packed spaceship like ours, we don't just have a read my mind button. We need a way to show not just a couple of words, but 1,000 words in the blink of an eye on this screen.
Okay.
And I can't think of a way to encrypt 1,000 words into that tiny... Oh, wait. 1,000 words. Are you thinking what I'm thinking?
Not yet.
No, not a Caesar cipher. Come on.
Oh God, I hope
Picture
not.
is worth 1,000 words. Let's see if we can do icons.
Ah.
Let's seize the day, Explorer. There's a whole new world of graphical power waiting to be discovered. Let's get started, shall we? You'll be relieved to know that there's no need to fiddle with wires or new hardware today. You see, we'll be sticking with our wiring setup from yesterday.
Okay.
By investigating some advanced sample code, we'll coax our OLED to create intricate diagrams, moving shapes, and perhaps even some space-age art. Sounds exciting, doesn't it?
Indeed, it does, actually.
All right, how about we discuss some significant coding concepts?
All right.
Number 1, a do-while loop. To put it simply, is a while loop that is guaranteed to execute at least once. That's
Okay.
the only difference between that and a regular while loop. Number
Right.
2,
Okay.
switch function and case statements. Picture yourself piloting a spaceship through an asteroid field. You have a special navigational device that, based on the size of the incoming asteroid, can choose one of several maneuvers to avoid collision. This is similar to a switch function. The size of the asteroid is the switch expression. The different maneuvers are the case statements. For a small asteroid, you might merely adjust the course slightly, which we may call case 1. For a medium one, you might engage side thrusters for a sharper turn, which we may call case 2. For a large asteroid, you might have to go full reverse and change direction completely, which we may call case 3. The switch function evaluates the size of the asteroid and then executes the corresponding case to avoid a collision. The moment it finds a match, it carries out the maneuver and exits. This way, our spaceship can use the right maneuver at the right time to navigate through any kind of asteroid field with meticulous precision. This is just like our program, navigating through different conditions using the appropriate case statement. Take that, mighty space rock. You're no match for our anticipatory prowess. Number 3, bitwise shift. The operators for them look like this. Now, let's move on to the rather intriguing world of bitwise operations.
Oh, God.
A bitwise shift is essentially the process of sliding all the bits in a binary number to the left or right. When you shift a binary number to the left, it's akin to multiplying it by 2. Shifting to the right, it's like dividing by 2. Number 4, bitwise AND. The bitwise AND operation is like a gatekeeper for 2 binary numbers. It takes 2 bits at the same position from each number, checks them both, and if they are both 1, then the result is 1. Otherwise, it's a 0.
Right,
It's a
makes
pretty
sense.
picky gatekeeper. It is completely
Right,
different
and the
from a
or is
normal
going to be
AND.
one over the other.
With these concepts under your belt, we're even
Which,
better
we're not
equipped to
covering that?
navigate
Or
the
we
coding
technically covered
cosmos.
that? Never-
All right, Explorer. There's no new pseudocode today because we're simply putting our new OLED display through its paces, just like a rigorous pre-flight check. It's absolutely critical to ensure all systems, including our display, are in top-notch condition before the launch. Imagine trying to juggle avoiding space rocks while also fixing a faulty display in zero gravity.
I've done it
Not
before.
my idea of a spacewalk
I'm
in
gonna
the
do
park.
it again.
So, today's all about making sure our OLED is up to the challenge. Ready to take a look at the line by line for the graphics code? I bet you are. I've also added it to your mission resources, so be sure to glance it over. I'll just be here, waiting patiently for your return.
Hello, everybody, and welcome back to day 22 of the.
Bye, Alex. Bye, Alex. Meow. Fractal patterns are always fun. Yeah, I could this. I feel like we're in danger. Okay, before I go any farther, I do want to showcase what we at least got on the display from last time. So before I do anything, let me plug the board in so you all can see at least what we did. For those of you that weren't around. So let me switch scenes because this is just cool, straight up. Boop. Okay, so what we have is the same wiring setup that we're going to use for today. We have our board here, and then we've got our little display, and then tied into it, right? So we've got power, ground, and then the system clock in serial lines hooked up to the board, which is very similar to a lot of other components that we've worked with. That seems to be a pretty recurring theme. And just like that, that's what we've got. Exploratory lander, hello world, stand by. So, getting this text on the display is going to look fairly complicated. This is also new territory for myself, because you don't just simply tell it, here's the text in one line, make it just appear on the display. You have to actually position the text and its offset to the text that needs to happen below it, or above it, or adjacent to it, so on and so forth. So we're going to take this real slow to make sure that we don't get lost along the way. And I'm going to attempt to keep, both of us hopefully in the know. I anticipate this being fairly complicated looking, but I'm very much looking forward to the idea of symbols and icons. I did not think we'd get into icons this fast, but yet here we are. Let me see here. Okay, good. Okay. So, first things first, here is our wiring setup, which is exactly the same as last time. We've got our ground and 5 volts, which then tie into the board at the respective connections. And this I found interesting, and I didn't anticipate this. Now, I haven't had the opportunity to look into the why behind this, but I 100% would have thought that being that this is a display, I thought for certain this was going to be a digital pin requirement. That's not the case with this piece of hardware. This hooks up to the analog pins that are at the bottom corner, which we haven't done a whole lot with. We're hooked up to analog pins 4 and 5 for the system clock and for the data line for this display, which, I'm gonna be honest, I don't know why. I'm hoping that information is either going to be revealed to us, and if not, I'm going to go find it at some point. Not right this minute, but I definitely foresee that being something that if I don't see it by the time we're done doing this, I'm going to know why. Because I don't quite understand why this particular piece of hardware that has all these controllable LEDs is down here. Everything we've done has always been on a digital pin and PWM if required, which, I'm not gonna lie, I kind of thought that we were going to be required to plug the display's data line into a PWM for pulse width modulation, if you remember. Pulse width modulation is what we were able to do to rapidly blink an LED on and off by turning the power on and off, which I guess technically speaking we don't really need for this, right? Because this is data transmission to make what we want to appear on the display. So I guess PWM wasn't really going to be a requirement, but I don't know. I'm just thoroughly surprised that it's on the lower portion of the board. As in goes the shock. But let us get our project rolling here, because I'm very curious to see what this is going to look like. First things first, we're going to get up and we'll make a new project, because today is day 22. So let's see here. We're going to do a new sketch. And this one is going to be called Day 22. No, you're not going to do it for me? Alright, fine. Day 22. Alright, cool. Alright, so we have our void setup in loop, placeholders, and we're just going to dig into this. So, let's see here. So it says, even our new OLED display is a bit small. If we have large amounts of information to display, but this new display isn't limited to just text. The 128 by 64 pixel display, and we can turn any of them on or off the display, whatever we really like, including graphics. Today we're going to run a readiness check, in quotation marks, to our new display to test out its full capabilities. Alright, let's see here. So parts, electronics, concepts. We are working with a new class today. Interesting. Okay. So before a void setup, we have to include the libraries that we're going to need. We always have to start with the Arduino class, because if we don't include that, that's the class that allows us to interact with the board. Always, you've heard me say that every day, probably except day 1, because we're installing software. But we have this new one, wire.h. So interesting. I'm surprised there's no flavor text next to this. It's just here, which this wasn't a part of last week, this wire.h class. So I'm going to imagine this is probably involved for making the graphics on the screen, for either drawing a wireframe or maybe being involved with making the pretty pictures happen. I don't know. We'll see. We'll just keep going. I'm sure we're going to have comments here that are going to Could explain this out a little bit. Extensive documentation for this library can be found at the GitHub for those wanting to dive deeper, but we will explain all the functions used in this lesson. Okay. Alright, so this is the library we saw last time. This is the one that allows us to interact with the display. The U8G2 library. As far as I understand, I believe that's the part number for the display, and they just so happened to name the library after that, which honestly is good. Makes the text a little bit more readable. Alright, now let's see what we got here. Construct our lander display handle using the same constructor from day 21. Okay. Now, they didn't really go into detail on what we got going on here, but a little bit of context clues that I remember from other things we've done with other devices that have serial and clock lines is that when you make an object in the C+ language, you're creating an object, right? And the name of the class of this object is this really long gobbledygook that we have here. U8G2 SH1106 underscore 128 by 64 underscore no name, and then underscore F HW, I'm assuming for hardware, and then underscore I2C. Now, I2C is the protocol that we're using to speak with the display. That they touched on a little bit last week, but very, very briefly. They just simply said that's the communication method between our board and our display. And then this that we called lander display, or excuse me, lander underscore display, is the name of our object. So anytime we want to interact with the display, we're going to interact with the variable called lander underscore display. We've done this with the 7-segment display. We've also done this with, what was the other thing we did this with? We created an object with a piece of hardware. What was that? Oh, the buttons. Yeah, the 4x4 keypad. We also did this too, where we made an object and we interacted directly with that object's name. And then after that, I'm gonna be honest, I don't know what this stuff is for on the end. It doesn't quite clarify. Again, I'm imagining this has something to do with the fact of the part and then the state that it's supposed to be in. I would think, I don't know this to be true, I would think this must mean that the object is off, like all the LEDs are off when the display is initialized, because before there was code on it, there's not even a backlight, it's just darkness, because this is not a backlit style display. Because some displays have a backlight where there's just a solid light behind all the pixels, and then the pixels come on or off, and then the backlight shines through them and you have your object. This particular display that we're looking at, each individual pixel is its own backlight. There's no central light. So if all the pixels are turned off, the display looks like it's just off. There's no brief indication of anything from that display that it's even got power until you send data down the line. That's at least my understanding so far onto what we got going on here. So we're making the object, and then I'm assuming this has something to do with the way we're initializing it. Okay. So in our void setup, void, interesting, okay. Now, normally we don't have something in the parentheses of the void setup. Why do we have that? Uncomment the next line of your display shows text upside down. Okay. That's a little unusual. I don't know why that's there. I'm not particularly sure why we're passing nothing into a function that returns also nothing. Because to pass void would be like ending you nothing. Here's my nothing. I don't know why we're doing that, but I'm pointing it out because I don't understand, but that's okay. Maybe we'll find some understanding as we go along. Okay, so there is our line of code to initialize the display with the begin command. We've seen things similar to that before when we would initialize the serial console, where we would see things in that little text box that appears on the monitor here. serial monitor. It's usually down here at the bottom. And then I am going to uncomment this for the display because I did find out that I plugged that board in upside down, so the text appears upside down. So to save me from having to rewire it, I'm just going to uncomment that again. All right. Ooh, yeah, void loop void. There's another one, void loop void. They did that here too. I don't really feel like that's required. But I suppose when we're done building this, I'll take those back out and see if it does anything unusual. Because I'm not really sure what it's doing there. So before I forget, let me add to our void loop our nothing. I am going to give you nothing. Isn't that exciting? All right, before I do anything else, let me validate that. That is very particular. I am compiling. I'm beeping and booping. Man, that has taken a very long time just to get checked. Okay, alright, no, it's valid. It's not upset about the fact that I put nothing into a function that accepts nothing. I mean, is that like going up to a closed business? Like you roll up to your bank and all the lights are off and the little sign says closed, please come again, and you just show up to the door. You don't even pull on the door, you just look at it and you go, and then leave. You don't say anything, you don't even pull the door. You're just sad. You're just sad. Why are you so sad? Shut up after closing. I tell you, it's so weird. Alright. Let's grab a little bit of this action. If nothing else, they piqued my interest on that. Okay. So we have a constant. It's a byte in size because it's below the number of 255. Bytes are anywhere between 0 and 255. Hey Pyro, welcome on in. And this is called test page count. And is that equal to 13? Now that's a hard-coded number because we declared it a constant, which means this is not going to change throughout the execution of the code. We cannot change it because it's a constant. And then it looks like we're going to enter into some code here that I did not grab the entire. That's okay. This for statement is very, very long. I just need to make sure I get the bottom curly brace. So if I hit the validation button right now, it's not going to validate, but that's okay because what we need is further down in the code. Okay, so let's see here. So for unsigned integer, display frame is equal to 0. So for an integer of 0, while the display frame is less than test page count times 8, we're going to increment display frame by 1 for each cycle. So our test page count is hard-coded at 13. Okay, so what that probably means, if we take 13 times 8, it works out to 104. The display's 128 by 64. I would have thought that would have been a full page worth of stuff. I don't know. We'll see what kind of explanation we find further down here. And then we start the loop, and the first thing we do is clear the buffer. Now, there's two actions that's involved with making stuff appear on the display. The buffer is what we have in memory that we're going to send to the display. Clearing the buffer does not clear what is on the display. It just wipes what's in running memory. We'll find the code for actually clearing the display, I'm sure, a little further down. But there are different sets of that, which, yeah, talk about getting a tad bit confusing, but I think we're all right so far. Okay, now we get to play with coordinates. Oh boy. All right. Clearing the buffet. I mean, yes, I wholeheartedly would agree with that statement. All right, let's see here now. So we're going to set the cursor with the set of X and Y locations of the upper left bit of each string. So the cursor is in relationship to, you see that blinking thing on my screen right now? Where it's just going blink, blink, blink. That is my cursor that's placed right now somewhere within the code, right? And if I click it over here, well, now the cursor's up here between the I and the S of this word of display. If I bring it down here, it shoots me all the way back to the beginning of the line. The cursor is where we're about to display text or display something on the display, whether that's in icon or text or just something on the display. Thankfully, we do not have to turn each individual pixel on and off to like hard tell what things are supposed to be on or off, but we do have to tell the display where our cursor is on it, and then we have to position the items on said display. So hang on a minute, let me get paint up here, because I think we need a little bit of a, I need a little bit of a visual, right? So say this is our display, right? And we have some text that we're going to have on the display, right? So what we need to do is tell the code where our cursor is going to begin somewhere within the display. Set that, and then let it position it within the display. Now further down in the code, we could very well just end up writing more text directly on top of the text we're on if we don't shift the stuff that we've already typed, right? So I could just straight up take my text without shifting it, right? And just draw over top of it, and now I've got a mess, right? So we have to keep track of where we are in the code so that we could tell the cursor to bump down so far off of the stuff we already have, you know, or work on our alignment. So we have to keep track of where we're putting stuff on the display, because it'll be more than happy to let us overlap things. It doesn't care. We have to be the ones to keep track of that. So we're going to kind of see that as we progress here. All right, so we're going to set our cursor. So the Lander display, set font. So the cool thing about this is that not only can we put text on our little display, we actually get to choose what font pack we're using. Now, I'm sure that you probably can't use the most elegant fonts if they're, you know, super noisy, because then you would run out of space on your display. But I'm sure that as long as the memory can hold it, you probably could use it. And there's a lot of fonts out there. So this one we're just so happening to use is a fairly basic, I think it's built in directly into the library. But if you wanted to use something else, then you probably can include the library of a fancier flavor of text. We're not going to do that, but just know that you have the option to set your font to whatever the heck you want. As long as it's available, you can play with it. And then let's see here. So then we have to set our font reference height, extended text, and then set our font position top. So this is where we're going to get some of those coordinates in to indicate, based on the font we're using, where's the top of the font, how long our font is, and then where is that first upper pixel of our font. So then from there, we can just work our way across the text that we're going to display. That allows us to keep track of where we started, figure out where we need to be, start there, and then where we currently ended off. So if we have more room to the right of that text to add more, then we can. If not, you have to go to a new line. Okay, And then we're gonna nab this stuff. See what other goodies we've got here. Okay. So, our y offset is the current y coordinate below all the previously drawn content. An offset is set to 0 to start at the top of the display. An offset is something that's incredibly common in 3D printing, where you have the print body, the print head, and then your offset would be how far, in this case, usually it's the Z offset, where you'll find that you always have to make adjustments, is how far you manually make the head be closer or further away from the object, right? So in the case of our code, the Y is going to be the upper corner of the display, right? And if we want to offset that further down, then we can by changing that number. I would think we would be using positive values, because I would think if you did a negative offset, you'd draw yourself directly off the screen, which I'm sure the code would be more than happy to do, but the problem is you're not going to see it. So you do have to be careful if you play with an offset. And then thankfully, this is where the code class, where the coding library helps us a little bit here. So draw centered string. So in the middle of the display, because that's what this particular class object does. And then it looks like an offset of 0, 0, which is just the beginning, the words exploration lander. And then right here we got a note of centering it, which sounds great. And then to leave the title above each display, we add the maximum character height of our current font to the current Y offset. So we're going to take our Y offset, which is currently 0. It's big fat 0 because we didn't do anything with it. And then we're going to add that into our lander display, get maximum character height of our current font. So what does that look like? Well, there's going to be so many pixels to indicate how high a particular letter is in our text, right? So we can see here, if we take a look at our text, that the P in exploration sticks down a little bit, right? By the way the font displays. So it's going to account for the fact that the letter P is taller, technically the tallest letter in our phrase that we're going to have appear on the display. That's then going to permit us to figure out where we won't accidentally overlap it, and then be able to continue drawing more stuff on our display below it. So that's why we have the offset. It allows us to figure out where we are and then how we get underneath it. Normally, I don't bring all the comments over, but this is a fairly complicated topic, so I'm going to bring them over anyway. Okay. If you'd like to just view a single page, just uncomment the next 2 lines and set the page desired to the first line. Constant byte display page 12. Display frame at 7, and then pipe that to display page less than 3. If you'd like to just view a single page, just uncomment the next 2 lines and set the page desired to the first line. Interesting. Alright, so that means we're going to cycle through multiple pages of stuff we're going to look at, right? So it's referring to this more like when you're like reading a book, how you read everything on the one page and then flip it to go to the next page to be able to flip through the different screens. That sounds like that's what ours is going to do. This allows us to be able to pick out a particular page and view just that, so it doesn't cycle through all the information, but this gives us the option to be able to at least do that, which is neat. All right, so we're now going to display the appropriate page for our current display frame. Since each page is displayed 8 times, we shift the display frame right by 3 bits, which is a fast way of dividing it by 8. Fast, you say? Very fast. It's in capital letters. That must mean it's important. All right. So let me see here. So we got this stuff. All right, we're writing the function for that centering of things. Okay. Which means that's the bottom of the main loop. That's the bottom of the for loop. So that should mean if I just grab just these things. And pop them in here. I should be able to save that. Okay. All right, as anticipated, we're gonna get a little messy here with what we're looking at. So let's see what we can make sense of this. So we're gonna go into a switching statement. The switching statement is multiple cases of things we could potentially end up doing. Hold on, let me grab my stylus here. Because they very briefly described what a switching statement is, but I kind of want to go a little bit more in depth onto what that exactly means for the rest of us. And I feel like that concept definitely requires a little bit more than a few what-ifs here. Okay. So let's dig into what a switching statement is. All right, so we have in our example, we're going to talk about buying groceries, right? You go to the grocery store, and then you're going to buy food, right? And that's our variable food with the world's thinnest pencil I think I've ever seen. Can I have the paintbrush instead? I feel like the paintbrush is more my style. I need to stop moving stuff around here. I want the brush. Yeah, alright, that's better. Alright. Alright, so we're gonna go into the store and we're gonna buy some food, right? Now, there's a lot of different cases of things I could buy in the store, right? Let's say our first case, this could be a chocolate bar. And then another case would be milk. And then another one would be bananas. Right? So once we have our food, we then can go into one of 3 cases in this example of things that can happen depending on which food we picked up, right? So we could say that we picked up bananas, right? So that could mean then that if we had a variable on the price on the bananas would be calculated by weight, right? And milk would be a hard-coded value, right? So the price would be equal to, I don't know, we'll say $2.50, right? And the chocolate bar has a price of $1.50, right? I apologize for my terrible handwriting. If I have a chocolate bar, then of course I want to pay the case of the $1.50, right? But if I have bananas, bananas are always sold by the weight, right? So we would have to calculate and do the calculation by the case, the use case, that we bought a product that requires pay by weight, right? So a switching statement gives us the ability to do different things based on the different use cases we can land into. Because of course, milk, we're not going to pay for by the pound, right? Or the kilogram. We're going to pay that by the set price of milk during that day. Bananas are sold by the weight, right? So we can have a different mathematical calculation, or in the case of, buying milk, scan the little barcode, right? And then go pull the appropriate price from the database, and it's just one thing, right? But bananas, you take the unit cost per pound and multiply it by how many of the bananas you have, and you can end up being that crazy person from the mathematical examples from back in high school of coach rolling up with a shopping cart full of bananas, right? And you're like, you're this guy, okay, that's kind of crazy, but here I am trying to learn things from a proud talking toaster on the internet, okay? that's what a switch case does, right? And what we're going to end up have is cycling through a couple of the different options that we can have based on which case number we come back with. So in the case of our fun little lander here, we've got case 0 through 12. Now, something I find really interesting is that there does not appear to be a default case. Normally, when you work with switching statements, you always end with a default case. A default case is a case that runs every single time in the event one of the other cases were not true. So, case 0 through 12 are the immediate options of what we're looking at on the screen, but a default case could simply be set to just do nothing, right? But normally you would want the default case to do something. The thing is that normally that's not omitted when you're looking at code. Even if you don't want the default case to do anything, just by declaring it to indicate that this switch statement doesn't do anything if it reaches this point in the code. So I'm a little surprised to see that we don't have one of those. It's not going to prevent the code from working. That just simply means that if none of these are true, then it truly will do nothing. But we haven't written it like that. So we've got case 0 here. Okay. Goofy background music. All right, so we've got some funkiness here. Display test ready. Display test box frame. And then we got circle, a lot of framing. I'm not super sure what we have going on here, but it looks like these are different options of what we'd be displaying based on the offset. And then these are the shifts that they talked about further up by doing a binary shift. I recognize these from some of the code I've worked on in my spare time. I truly do not fully understand them, but something else I do want to point out that is incredibly important is that the switching statement, if one of these cases is successful, the line ends in a break. Break means that if one of these is true, you exit. You don't check against the other cases. So if somehow case 0, 1, and 5 are relevant, well then case 0 will run this line of code. After the semicolon, it hits the word break, it stops. It then skips case 1 through 12, and then continues further down the chain of command. Now, as I had mentioned earlier, about sending things to the display, we've put a bunch of stuff in the buffer, and here we are sending the buffer. And then we delay 100 seconds. Milliseconds, what was that? 100 milliseconds, I think it's milliseconds. So it's fairly quick. But we're not done, because there's some more stuff we got to bring over. Yeah, there's still quite a decent amount of stuff we got to do here. So, I don't want to scroll too far. I just wanted to see quite where we're running off to here. Okay, so we're going to grab this next chunk. Now, everything that we're bringing over at this point is now outside of the main loop. The main loop ends right there, which means everything that we're doing below this only runs if it's called upon. So if we call the function by its name, that's when it's going to run. Otherwise, the loop will continue to go in circles until it hits something that requires it, and then it will go and get it. So this says, use the drawString method to draw a string in the display centered horizontally between the given x coordinate and the maximum x. Y coordinate is unchanged and text is displayed relative to the current font positioning mode of top, centered, or bottom. So we can see here that the name of our function was not built in. We actually made it. I didn't know that until we got down this far. So we are making the function, and we are then accepting the x and y coordinate. I was right on that part of where we're going to be on the display. We passed zeros to this function at the top because we wanted the lander text to be in the topmost left and then come across, right? Now we have to center it, right? So thankfully this is going to do the math for us to get it in the middle of the display. So we're going to see here. So we're going to take the x coordinate and then add in some multiplication here. We're going to take the lander's display width. We're then going to subtract the x coordinate, which is 0 in this case, from the code we're going to run. And we're going to subtract from that the width of the text we're passing, divide that by 2. So that should stick us in the middle of that space based on how long the text is in relationship to how wide the display is. And then we're going to call the method drawString, drawStr. And we're going to center the x, provide the y, and then the string is the actual words that we passed over to the function. Now, the drawStr does not make that text immediately appear on the display. The sendBuffer command is the one that actually makes it appear on the display, which actually means I was incorrect earlier. The clearBuffer actually is the one that does clear the display. I was incorrect in that statement. The one that I know there's another one that actually clears what we're putting in the buffer, or that goes into the buffer, and then there's the send commands to actually make it appear. If you couldn't already tell, this is a little confusing to keep track of, especially when you're reading it from top down. So I apologize if I lose any of you along the way. I'm trying not to fall off the school bus myself. So it goes. Okay, now we have some code here that I know for a fact I do understand, and that's always exciting. We have the height and width of our image, height of our lander image in bits, and the width of it in bits. So our lander height is 25 by 20. This is the part that fascinates me, how on earth we were going to do the image. Draw an image of our lander drawn with frames and triangles at location X and Y relative to the upper left corner. Now that relativity of the upper left corner has to be below the text we already stuck up there, right? Because we already have words that are going to appear in the upper corner of our display, and below that is where we're going to stick our image. If everything goes according to plan, which I kind of hope it does. Okay, so now we've got our function called display lander. It's a void function because it doesn't actually return anything to the code. It's going to do something with the code, right? It's going to actually make the pretty picture appear on our display. But the code, while it's executing, doesn't need anything from it. It's just going to say, oh, okay, I'll make sure to write that down. But then nothing else happens. Where they're going to take our X location and our Y location, and then we're going to do some wild stuff here. We've got our X location. We're manually adding 7 to the X location. And then we're declaring the Y location. We're not doing anything to that. And then we have numbers 6 and 5. What are these for? Draw frame. We're providing the X, the Y, the width, and the height. That's what the other 2 numbers are for. So a width of 6 and a height of 5. And as far as I understand, this is all relative in pixels, or excuse me, in bits, not pixels, which is why the number is as small as it is. And then in our draw frame, we then have the position at the top, the center, the left pod and right pod, respectful to what we're going to draw on the display here. That's the draw the frame, and then we're drawing the triangles at the locations that are given. I would love to know how you're supposed to figure out these values, because obviously this being a guided example, they went through the process of getting these numbers so we could play with them. But I would love to know how they came to this realization of how. So I'm hoping that we're going to get a little bit of guidance on how this comes to be, or if there's some other mechanism online that you can initialize to help figure out this part. Yeah, kind of curious to see what we're going to find there. All right, let's see what we got next here. So we've got another void function. This one is called display test ready. And then we've got, it accepts our Y offset, which makes sense because we want to know how far down from the stuff above we need to be away from so we don't overlap it on accident. And then we're passing over the frame. Y value halfway between top and bottom of drawable area. Okay. So this I'm gonna nab in one block. All right, let's see what we're working with here. All right, so our lander display of height, right, so that gets our offset divided by 2. Since our lander drawings location is set using the upper left coordinates, we will subtract half our drawing's height to center it vertically. We will also shift it right by adding a padding amount to the lander's X coordinate. Now, what padding does is that allows you to slightly shift something left or right. Now this, in this case, it's our X-axis. So we're purposely shifting it so it's not butt up against the edge of the display that we're working with. It's very common to see padding added so that text does not immediately show tight up against the edge of a display. Because usually when something is tight up against the edge of the display, it's a very thin wire frame, and it might make it hard to read for some people. I find that if something is really tight to the edge of the screen, I know I have trouble reading it, which adding that little bit of padding adds a little bit more visibility and also a little bit more accessibility, because not everybody can read this stuff when it's really tight to the edge of the screen. Now our screen's really small, and if we're really close to it, it's probably not as big of a deal, but if you're looking at like a full-size monitor and your text starts in the very top upper corner, it's going to be hard to see if you're sitting at, more than a foot worth of distance away from the monitor. And the same kind of idea is what we have here. All right, so then we're also going to shift it right, adding a padding amount, which is what we're doing here. Which is fine. And then display lander padding. Right, okay, what do we have here? Front image of our lander relative to the upper left. Oh, that's what we saw up top. Okay. We're then going to blink the ready message by only displaying it every other frame. Hi, Pine! Welcome on in. Which makes sense because there is no concept of a blinking function that comes with writing stuff on these screens. We have to make the thing appear, erase it for the next frame, and then redraw it for the next one to make it blink on and off. It's a very manual process for working with one of these displays, which I'm not too terribly surprised by, but I think getting a pretty deep understanding of how to do something with one of these definitely going to require some decent practice. But that's okay. That's why we take the time to learn. All right, so right here we have our if statement. Determine a remaining space in the right of our lander for our message. Hi, Sid. Welcome on in. The lander image extends from its starting X position plus its width. So we're going to take our X offset and make it equal to the lander padding, and then add in the lander's width. That gets us our X offset. And then get the height of each text line since it's used multiple times below. So we're going to get our maximum character height and then use it quite a few times down here. We're going to set our font position centered, Y coordinate relative to the center of the font height, and then draw centered string. So we're going to involve our X offset, our Y's center position, minus the height of the text, and then draw the word begin. Do a similar thing, and then below begin, add the word hardware, and below that the word test. Okay. Now that we have that, I am thoroughly grateful that they added this code block layout. This makes this much easier to follow along with. Much easier to bring over too. Alright, so page 1. Display filled in hollow boxes with one moving every frame. I'm doing good today, Sid. I hope you can say that you are doing the same. I am collectively melting my mind with our display we have here. For those of you who have wandered in, by the way, all this crazy level of code we're playing with is going to eventually end up on our little friend that we have right here, which right now it says hello world. But when we're done, that display is going to say a whole bunch of more stuff. And we're slowly working through the idea of building our several different displays of information. Yeah, coding. You better believe it. You're going to talk about melting minds. I know I'm melting mine. Okay, so here we define the constant. This is done so we can change it in one place. It also makes it clear what the meanings for each number are in the code. It changes code like drawbox 5, 10, 2010 to drawbox, the X offset, the Y, and then the width and the height. That makes reasonable sense. I do like reusing meaningful names than dealing with gobbledygook. That helps greatly. Okay, so we've got we're going to draw our box, which just literally says draw box in quotation marks, which is hilarious. I wonder if the word box is going to appear in there. I don't know. It's a function we're passing this to. The draw str method draw a string in the display centered horizontally between the given x coordinate and the y maximum x. Y coordinate is unchanged and text is displayed relative to the current font position, top, center, or bottom. Okay. With an offset, we draw the box. What's in the box? It's some code and some letters and some symbols. We're then going to draw our frame. I have really nothing additional to say about this. I'm going to peruse through the rest of the code here and see. So we've got, yeah, multiple pages. Page 2, I think it's at what, total of 8? Page 4, page 5, 6, 7, 8, and 9. Alright, I'm going to bring over a big chunk of this. Because I'm going to tell you right now, other than knowing that this was laid out, page 2, page 1, so that's where I copied from. All I have to really say in rebuttal is that it's really great to indicate what the code, if it's like something like this, each page is a logical break between the big comment block and then the indication of where it begins and where the next one ends. I don't really have too much to say on these other than the fact that this is what the code looks like for drawing some more complicated stuff. I kind of understand now why this particular component in the kit was near the end of the 30 days in space exercises. This is fairly complicated. Oh wow, we have multiple. Okay, alright, yeah, we're just gonna keep scooting down here. 499 lines of code, including comments. That is bonkers. Straight up bonkers. If I got everything, that should compile, and if not, I'm just going to bring over the whole sketch. I've been bringing it over in chunks, but if I can't open device com4 system, can I find the file specified? That's okay. I think I missed something. And you know what? With 500 lines of code, I'm not going to go looking for it. I usually like pulling this over in chunks, just because it makes it a little easier to read instead of looking at everything all at once. Okay, cool. Whatever I missed, it's here now. Page 12 is displaying the bitmap overlay mode. Yeah, I mean, I have full confidence that this is going to work, but I definitely feel like we've got some pretty heavy concepts here. Look at that! Well, all be the symbol for what to draw is straight up put in the code. I was actually kind of wondering about that for our symbols. Well, that's pretty cool. I'm not gonna lie, I didn't think we would actually see the symbols that we're gonna display just be like that in the code. I thought it was gonna be, you know, like memory addresses or something. Or like the binary that would have made up the image, or some kind of conversion to take the pretty picture from what we're gonna see and convert it into machine code. But ironically, we could just pass it the symbol, which, boy, that makes a lot more sense. Yeah, and then we have these bit shifts, which it did briefly mention this about shifting the most significant bit. Or no, it didn't say that. It said the rightmost 3 bits. What I said is a different thing. There's the most significant bit and least significant bit. In this case, we're shifting 3 bits. I'm gonna be completely real with you. There are a difference between all 3 of those. I do not have the capacity to know what that is right now. I just know that they're different. And there is an explanation for all of them, and I don't know what that is offhand. I'm very curious to see what on earth this is going to end up looking like. Other than, I mean, sure, all right, that's location data on where things are going to be on the lander's display, which that makes sense. But other than being cool to look at, we would definitely require a little bit more guidance to kind of get an idea of how this kind of comes to be, which I'm a little surprised, because the 30 Days in Space franchise has been pretty good at explaining like the concepts and the code as we go along. This very much just kind of dumped this on us. Cross-fill width 24 by height. Yeah, cross-fill the bits. Yeah, this is memory addresses or bit addresses. This is certain. Yeah, this is the complicated good stuff right here. And I half wonder if they wrote this or if they used something to generate that and then put it in here. And the fact that there's no comments about that is what bothers me a little bit. Offset from height. All right, well, that's about it, all I could think of. Let's hit it to the display and see what we actually get. So I'm going to go to the bench camera and I'm going to upload the code to our project. Let's see it break. Why did it break? Can't open device COM4. Oh, that's probably because I'm not on COM4, am I? Probably not. Let's see here. Yeah, I got an error. Just so you guys see what I'm looking at here. Excuse me. The this is nothing to do with the actual code. So when you open up the project, I briefly had a different console open. So the board that was already plugged in was held hostage by the current window that was open, which means that this project I opened doesn't have access to the hardware that's physically connected to this computer. Really easy way to fix this. I'm going to close the project and reopen it. What that's going to do is it's going to then relatch on to the project board because it's present. Because that'll be the first COM in the available lineup. So I actually don't even need to do that. All I have to do is just do that. I'll reopen up the Arduino IDE. And that should likely resolve that. So I'm going to upload, compiling. Nope, it's not happy. All right, that's okay. I think we're going to have to manually fix it then, which is not a problem. We just have to tell it to not be silly and use the correct serial. Let's go again, shall we? Okay, beautiful. And then we're going to give the project a moment. Oh, you know what's funny? Hang on, I had that upside down because I uncommented out the line. Hang on, I gotta find the line in the code to flip our display back around. I want to look at it right side up. That's better. ASCII page 1, ASCII page 2. Transparent bits. Alright, and we've cycled back through to the other page. That's fascinating. I'm sad that I can't really express to you all a little bit of a better understanding on how we came to this conclusion. But as the knowledge grows, the understanding comes with. That's really cool to see, though. You know, it's really funny that ASCII reminds me of a particular raccoon from this morning. looks like said raccoon might have followed us in here, because that ASCII looks an awful lot like that message I saw this morning. That's fun.